Hi, everybody. Good morning. So today is Monday, April 22nd. By the way, do you receive a class smart eval class evaluations?
I haven't been
survey?
emailed about it.
Mhm.
Usually they send an email out.
Oh, you haven't received an email? You did? Oh, okay. So, yeah, if you, maybe it's in your junk box, probably. Okay. So, if you, please help me to fill the class evaluation survey. Your comment is so important to me. And I give you extra credit for the survey. If the overall response rate is 90% and above, then everybody will get 0.5% extra credits. If the response rate is 80%, everybody will get 0.4. 70%, everybody get 0.3. 60%, 0.2. 50%, 0.1. Okay, so thank you. I'm so happy to be your instructor this semester. I know this course is challenging, but I hope you learn something in this course. Okay, and by the way, this course is only offered in the spring, but it's also offered online. Okay, so of course, I hope you can pass the course, but you need a D to pass, right? But if you don't pass it, then there's some online course, and the online course and our course use the same set of homework. So hopefully, yes. Okay. So if you have any questions, please feel free to ask me. Mhm. So today we will finish 12.7, and then Wednesday you will have the homework and quiz. By the way, this 2 weeks you're gonna be very busy. So please take a look of your homework. If you don't get perfect scores of your homework, please come to see me. I hope to work with you, look at which problem you haven't got it right. And then yes, show me your work and let's figure out the mistake to make sure you get your homework perfect scores. So please come to see me this week. So I prefer you to come to see me like this week. We can take care of all the previous homework and also your exam 4 based on chapter 10 and 12.7. Okay, so if you understand all your homework about 10.1, 10.2, 10.4, and 12.7, then you can do better on the exam 4. So this week, yeah, come to see me more. Okay, so yeah, if sometimes you forget about my office hours, I'm usually like free after class, and I have a class at 1:50 today. And but that's the only one more classes. That usually I will be in my office. Okay, and you can see my schedule outside of my office. Okay, so you can see what time I have classes, and beside that, I will be in my office. Okay, so we only have 2 weeks of classes left, and then our final exam is on Monday, and then we finish. Let's try our best. And by the way, the last week we're gonna have our class picture, and you also can show me your notes. Remember, we have the extra credits. If you miss no more than 2 classes, you have so less than or equal to 2 absences. Excuse absence doesn't count, of course. Then you will get 1% extra credit. And if you show me your notes in the last week of the class, you also get 1% extra credit. And also the class evaluation. If you have me to fill out the class evaluation, if the overall response rate is greater or equal to 90%, then all of you can get 0.5% extra credits. So you can get at most 2.5% extra credits. Okay, and yeah, please come to my office and get your homework perfect scores. We raise your homework percentage from 10% to 20%. So I hope this will help your overall grade. Okay, yes. So especially focus on your homework 10.1, 10.2, 10.4, and 12.7. Because once you understand those, you can do better on your exam 4, which is next Monday. Okay, so last time we talked about L'Hopital's rule. So L'Hopital's rule, when you see the limit of some like quotient, and when you plug in a number, you get 0 over 0, or you get infinity over infinity, then you can use L'Hopital's rule. Okay. We compute the limits of the derivative of the numerator over the derivative of the denominator. And let's see. So let's continue on this problem. We have limit x goes to 2. What is the derivative of 3x? 3. Okay. But look at the denominator. Denominator. We have square roots. So this is a composite function, right? This is like u to the 1/2. Right, everybody? We recognize it's a composite function. And u to the 1/2 derivative, what is that? You move the power.
Oh yes, it's 1/2.
To the negative 1/2 times the u prime. Right, everybody? And derivative of a constant is 0. Okay, so that's why this is the derivative of the denominator. Let's continue. So we have limit x goes to 2. 3 over. Okay, we have fraction in a fraction. The 2. And do you see the exponent is negative? It means it's in the denominator. So 2 plus x to the 1/2. What is 2 plus x prime? 1. Yes. The derivative of 2 is 0. The derivative of x is 1. Okay, good. When you see fraction in a fraction, we can simplify it. Right? A over b over c over d is a over b times d over c. Right, everybody? And therefore, we get limit x goes to 2. The 3 upstairs or downstairs? The 3 is upstairs. 3 is like the A, right? And the B is like 1. And the 1 here, this 1 is like the C. The C is downstairs. And the 2 times 2 plus x to the 1/2. This is like the D. So when you divide it by a number, it's the same as you multiply by the reciprocal. With it. Right, everybody? Okay, we're ready to plug in. What's 3 times 2? Oh, because we plug in, we don't need to write the limits. 3 times 2 is 6. And we plug in x is 2. Right, everybody? We plug in x is 2. Replace x by 2. What is 2 plus 2? 4. Square root of 4. 2. 2 times 6? 12. Yes. The answer is 12. attendance. Thank you. Right, everybody? And this problem, you realize that the limits, x goes to 2. We first plug in the 2, we get 0 over 0. So we use L'Hopital's rule, and we take the derivative of the numerator over the derivative of the denominator. Make sure you change this to the standard form before you differentiate. Okay? Did I write on the formula? Yeah, last time. Yes. This is the formula of derivative. We learned about power function, exponential function, and the log. Okay, those 3 formulas. Okay, if you don't see a function similar to that, it might be a chain rule. Okay, so it's a chain rule. You multiply by u prime at the end, and negative exponent, it means it's in the denominator. So you gotta simplify to a simple fraction. And then we can plug in the number again. Okay? Any questions about example 4? All good? Okay, let's see example 5. Suppose f and g have the following values. So all the previous example, we were given the formula of f and g. Okay, we know we're given a rational function or quotient. Okay, but here, this problem, we don't have a formula for the f and g, but we know f of 2, f prime of 2, g of 2, and g prime of 2. And assume all functions are continuous. Find the following limits. You may need the product rule when using L'Hopital's. Okay, let's see. The first thing we do is plug in the number. Okay, let's plug in x equals to 2. If we plug in x equals to 2, we get f of 2. Yes, minus 36. And the bottom, ln g of 2 minus ln 1. And f of 2 is negative 6. Negative 6 squared is 36. Right, everybody? So the numerator, we get 36 minus 36, which is 0. Okay, now I remember to charge my computer. Okay. How about denominator? G of 2 is 1, right? Ooh, so this is ln1 minus ln1, which is 0. Do you see we get 0 over 0? That's why we can use L'Hopital's rule. So L'Hopital's rule tells us that this is the limit. H goes to 2. And the derivative of the top, so the top prime, and the derivative of the bottom prime. Let's look at the top. We have something like chain rule. So u squared. What is the derivative of u squared? So u squared derivative is 2u. Right, what's u squared prime? 2 times u times u prime. Right, everybody? So 2 times u times u prime, which is f prime of x. everybody? Okay. Denominator also chain rule. Okay, so LNU. Oh, by the way, the 36, is a constant, so the derivative is 0. But then here is LNU. What's the derivative of LNU? Yeah, 1 over U. And exactly. So we have 1 over G of X and then times D prime of X. Right, everybody? We use the chain rule. And the derivative, by the way, LM1 is 0. Right, everybody? Mm-hmm. Yeah, LM1 is 0. Okay, and the derivative is also 0. All right, we are ready. Now let's plug in the number. So we have 2, and then f of 2. What is f of 2?
-6.
-6. What is f prime of 2? 5. And then 1 over g of 2, 1. G prime of 2, -1. Right, everybody? So your homework, you have some problems similar to this. Okay? But do you see here my number? So the problem generate different numbers when you work on it. The number I get is easier, so 1 over 1 is just 1. But in your homework, maybe this is 3. And you have 1 over 3, it means you have to put the 3 upstairs in your homework. Mm-hmm. Okay, but for my problem, the negative cancel. And what is 2 times 5? 10 times 6? 60.
So 60 over 1.
Yeah, 60 over 1. So just 60. Mm-hmm. Okay, everybody? So this is part A. Okay. Part A. And now let's look at part B. So part B, we also plug in the number first. Okay, let's plug in. What's G of 2? 1. And then F of 2? -6. So -6 plus 6. Denominator, G of 2. Oh, 1 minus 1 times F of 2, -6. Do you see 0 over 0? Yeah. So we can use L'Hopital's rule. So at the step, when you use L'Hopital's rule, make sure you put LH. Okay, so is the top prime. And the bottom prime. Prime. Okay. So copy down the top function prime and the bottom function prime. Okay. I'm going to do you see something times something? You need to do product rule. Product rule. What's product rule?
UV, you find this.
What's a minus?
What?
Yes, plus.
U prime V plus UV prime.
Yes, very good. Okay, so we have limits U prime, so G prime, V is f of x plus 6, right? Plus U V prime. So f of x plus 6 prime. Right, everybody?
Yeah.
Mhm. Denominator. D of x minus 1 prime times f of x plus g of x minus 1 times f prime of x. Right, everybody? Okay, let's see. Oh, so we continue. This guy, it becomes f prime of x. And the derivative of 6 is 0. Right? So let's continue. Copy this down. Make it bigger. Okay, so g prime x f of x plus 6 plus g of x. And now this is f prime of x. Because the plus 6, it just becomes 0. So it becomes f prime of x. So far, so good?
It's getting too long.
Yep. Let's get too long. But at least we don't have quotient rule. Product rule is long enough. Okay, and then here is what? D prime of x times f of x. And then plus g of x minus 1 times f prime of x. Right, everybody? Let's plug in numbers. What is g prime of 2? Negative 1. F of x, f of 2. Negative 6 plus 6, right? G of 2. 1. F prime of 2. 5. Okay. Denominator. G prime of 2. Negative 1. F of 2. Negative 6 plus G of 2. 1 minus 1. F prime of 2. 5. Everybody? Do you see minus 6 plus 6 is 0? 0 times whatever is 0. And 1 minus 1 is 0. So this term is also 0. So our numerator is 1 times 5 is 5. Denominator. Negative 1 times negative 6? 6. Yes. So this is our final answer. Part B. So this problem, we don't have a formula for F and G, but we know the value. Okay? So we use the chain rule, the product rule, and then we plug in the number in. So your homework, you have a homework problem like this. Any questions so far? Okay. All right. Let's continue. But in your exam, most of the problem will be given a formula. So you take the derivative of that. Okay, so let's look at this one. X goes to 0. Let's plug in x is 0. Plug in x is 0, we get 7 minus 0 is 7, right? Now n. What is 1 minus 0? 1. Yes. Over e to the negative 0 is e to the 0. Let's subtract 1. What is ln of 1? Yes. What's e to the 0? 1. Ooh, that's why we have 0 over 0. Okay, so the first thing we do, plug in the x values to see if you can determine. Okay, 0 over 0 we cannot determine, so we need to use L'Hopital's rule. Okay. So L'Hopital's rule, we compute the derivative of the top and then the derivative of the bottom. Derivative of the top. What's the derivative of the top? Something times something. Product rule. Yes. The product rule is the first factor prime times second factor, right? Plus first factor times the second factor prime. Right, everybody? The numerator. Now the denominator, what's the derivative of e to the negative x? E to the negative x derivative, what's that? Do you remember? Yes, negative e to the negative x. So remember those three formula. X to the n prime is what? Power rule. And x to the n minus 1, right? How about e to the ax prime? A times e to the ax. You're familiar with that? Do not multiply by the x. We don't bring the x in front. Only the coefficient. We bring it in front. So therefore here, the a is like negative 1. So we bring the negative 1 in front. E to the negative x. And last one, natural log of x. Derivative is 1 over x. So keep this in mind. And what is the derivative of negative 1? Yeah, 0. It's constant. Right. Okay, let's continue. So limit x goes to 0. What is 7 minus x? Derivative of constant is 0. Derivative of minus x? Yes. So negative 1, right? Negative 1 times ln 1 minus x plus 7 minus x. Oh, and then derivative of natural log. Do you see this is a composite function? What's the derivative of ln u? 1 over u times prime. Yes. 1 over u times u prime. In this problem, u is 1 minus x. Maybe in your exam problem, u could be like plus 3x. And u prime will be like 2x. Depending on what's inside the ln. Okay. And then the denominator, we have negative e to the minus x. What is u prime? What is 1 minus x prime? Yeah, negative 1. Okay, let's see. We can rewrite this. So negative ln 1 minus x plus, this is a fraction. We can combine them. So it's really up to you. You can combine them or you can just leave it like that, up to you. But then you multiply by -1. Can I just move the negative in front and change this? Can I do that? And over negative e to the minus x. Now we plug in x is 0. So minus, plug in x is 0. You see 1 minus 0 is 1. So ln1 minus 7 minus 0 is 7. Right? 1 minus 0 is 1. Over negative e to the minus 0 is 0. What's ln 1? 0. What's e to the 0? 1. So the top 0 minus 7 is negative 7 over negative 1. What's the answer? 7. Yes. So 7 is the answer. Because your limit is a finite number, your limit exists, so L'Hopital's rule holds. Okay? L'Hopital's rule holds when you have a finite number or you get infinity or minus infinity. But all the problem I give you, L'Hopital's rule holds. Okay, this is example 6. Any questions about example 6? No? All good? Okay, so this is then we finished 12.7. And how about let's have a review about chapter 10 and 12.7.
Were you going to cover the quiz?
Huh?
Were you going to cover the quiz?
Yeah, the quiz will be on this part. So let's see, the quiz about 10.4 and 12.7. Yes. So the quiz is on Wednesday. Okay.
No, quiz 6. Sorry, quiz 6.
Oh, the quiz 6. I haven't graded yet. Sorry. Let's go over that on Wednesday. Okay. Yeah. Okay. Weekend, my kids. Blah 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 blah. Okay. Let's see. Okay. Yes. So chapter 10, concept map. Let's have a review on that. Okay.
Do you think chapter 10 is easy? I felt like it was easier than.
Yes, because yes, I think it's easier than the last one. Because the last exam, the Lagrange multiplier and the maximum minimum is hard, and you gotta solve the system of equations. If the point you get is wrong, then the whatever after is gonna be wrong. And yes, and yeah, right. Okay, so chapter 10, we talk about 4 sessions, right? 10.1 is separable differential equation. And first thing you do, make it to the standard form. The standard form, you have your left hand side, just the derivative dy dx, and your right hand side, you need to separate it. Separate the function of x times the function of y. Okay, and it must be multiplication or division. You don't want to see addition or subtraction. If you see a plus here, then it's not a separable differential equation. It might be a first order linear. Okay, it must be a multiply. Okay, so then we move the y to the left hand side and move the x to the right hand side. Move, I mean either divide or multiply. Okay. So once you separate them, you can integrate both sides respectively, and then you might use substitution or integration by parts. And at the end, you plug in the initial condition to find the C. Okay, and then 10.2, linear first order differential equation. Linear is in the sense that the y prime and the y, they're both to the power of 1. Right, everybody? And first order, it means you only see y prime, you don't see y prime prime or y triple prime. Okay, so this is first order linear differential equation. The standard form, you always want to make sure the coefficient of dy dx is 1. If you have an x here, you have the both sides divided by x. That will change your p. That's why your first step, you have to make a standard form. If your standard form is wrong, your p is wrong, your q is wrong, whatever after is gonna be all wrong. So make sure you check your setup 3 times. You check yourself 3 times. You ask yourself, is it standard form? Is it the coefficient of y prime 1? Everybody say standard form.
Standard form.
Yeah, it's so important. Okay, and then our integrating factor is e to the integral p of x dx. Everybody say e to the integral p of x dx. Yes. And if you see something like, because if you see like negative 3 over x, the integral will be negative 3 ln x. By the way, the p, make sure if this is minus, the p should include a negative sign. And then e and ln cancel, but before you cancel them, make sure you move the negative 3 to the exponents. Okay, so the negative 3 belongs to the exponent. So it's not just the negative 3x, it's actually 1 over x cubed. Okay, so also check this again and again. Because then you use the integrating factor times y equals integral, the integrating factor times q. And here you have a product, but do we have product rule for integral? No, there must be a way you can simplify. You either distribute, combine the x power, or maybe you have some exponential function. When you distribute, you can cancel them. Okay? So simplify. And then you integrate, and then you get c. You plug in your initial condition to find the c. And this one, I need you to solve for y. The separable one, you don't need to solve for y because in general it might be hard to solve. But for first order linear, your y is just the right-hand side divided by the integrating factor. Okay, everybody? So you can solve for y. And then this is session 10.2. And then 10.4, we talk about applications. The first one is the logistic growth, right? And y is the population, and m is the limiting population. R is the growth rate, y0 is the initial population. And do you remember, everybody? The formula will be given. So you don't need to memorize the formula for this part. And the spread of the disease, the formula will be also given. But be careful. Don't confuse them. And the logistic growth, this is e to the minus RT. But for the spread of the disease, is e to the minus RMT. Okay, everybody? So even though I give you the formula, but make sure you copy them correctly. Okay, and then the continuous deposits. Remember, if you deposit the $D per year, your account is adding money per year. So you have plus D. And if you withdraw money from your account, then you have minus D. Okay, so in the exam, you get one of them. And this part you can solve either using separable or the integrating factor method. In the class, I show you the integrating factor method in class. And then I show you the notes with answer that I solved using the separable method. And then you compare both methods. Do you still remember which method you said was easier? Which one?
The first one that you did.
The integrating factor method is easier. Yeah. And then plug in the initial condition to find the C. And so two directions. I can give you the time, and then you tell me the amounts in the account. Or I give you the money, then you tell me the time. Okay? So, but if you have minus D, if you withdraw money from your account, it is possible that your account has no money left. So I may ask you, by the time such that your account has no money left. So you have to close your account. Mm-hmm. Okay, and the mixture problem, you won't see that mixture problem in the exam. Okay. And then 12.7, L'Hopital's rule. You plug in the number first. If you see 0 over 0 or infinity over infinity, then it's limit f prime over g prime. So it's not quotient rule, okay? It's quotient of the derivatives, but not quotient rule. This is easier than a quotient rule. And then simplify. If you see when you see power function, make sure you put them in the standard form. Like if you have 1 over square root of something, then you know this is u to the negative 1/2, something like that. And make it to the standard form. And then when you differentiate, you know you bring the power down in front, and maybe you use chain rule. Mm-hmm. And when you see fraction in a fraction, simplify them. Okay. And sometimes you might need to do L'Hopital's rule 2 times or 3 times. Depends on the need. But your goal is to get the problem easier. Okay? So if your problem is the derivative is getting more and more complicated, then you might not in this correct direction. You might need to simplify it before you take the derivatives. Or sometimes you can see, even though maybe the numerator get complicated, but my denominator is easier. Like if you have a polynomial, every time you use the derivative, your power jumps down by 1. Then you can still see some hope. Okay? Maybe at least I get my denominator is approaching to constant. Maybe my numerator, when I plug in, I get a constant, so constant over constant, I get a number. Or maybe my numerator will go to infinity, then you have infinity over a constant. You can still say, oh, that's infinity. Okay? All right. And the growth rate, who runs the fastest? Exponential function runs the fastest. And then the power function. Who's the slowest? The natural law. Okay? But you gotta be careful. You must have your limit x goes to infinity. If x goes to 1 or 0, do you look at this? No. Right. If it goes to infinity, numerator grows fastest, then your quotient goes to infinity. If the denominator grows faster, this quotient goes to 0. Mm-hmm. Okay, so these are the things in our next exam. Any questions? 7 minutes. How about we look at the practice exams and pick some problem and you work on it? Okay, did you want to start a new thing or look at your practice exam? Practice exam to practice some problems? Start the new things? Oh, okay. How about everybody? Okay. All right. Huh? Stuff?
New.
Okay, good. So yeah, practice exam is right here. So work on your practice exam and your homework. I will be in my office. So come to ask me questions. Okay. All right. I know sometimes your homework could be frustrating, especially the long one. If you have little mistake and you get the problem wrong, you have to redo it again. I totally understand the frustration. So I hope you can come and work with me. I can guide you and check your each step and let's figure out the mistake, and then you can get perfect scores on your homework. Okay, so 13.1 is review of the trig functions. So you don't need to print out the worksheet for 13.1 because we just go over it together. So when did you take trig? Long time ago? Last year? 2 years? Oh, okay. Long time ago. Okay, so let's review them. By the way, so 13.1 is review of the trig. So I won't ask you questions like this in the exam. 13.2 will be the derivative of trig, and 13.3 is about the integral of trig. So in the final exam, I will ask you one problem about the derivative and one problem about the integral. Okay? So 13.1 is review. It won't be in your final. Okay. So angles. An angle consists of either two rays or two segments in the plane with a common endpoint. The common endpoint is called vertex, and the two rays or segments are called sides of the angle, right? And usually we have initial side is the side from which the rotation begins. The terminal side is the side at which the rotation ends. So usually we have the XY plane, and we have the initial side here, and then we're gonna rotate, and this is the terminal side. So this angle is in the first quadrant. How about here? Ooh, and this angle is in the second quadrant. How about here? Ooh, this is the third quadrant. And then here, from here to here, this angle is in the fourth quadrant. Okay, a counterclockwise rotation has a positive measure. So we rotate counterclockwise, we have positive measure. If we rotate clockwise, so this angle, we can also think about we rotate clockwise like here. So let me think about it. I can put maybe this angle is 330 degrees. And this is coterminal to this is negative 30 degrees. Okay? They are the equivalent, they're kind of the same angle in the XY plane. So they're coterminal angles. An angle, when you add a multiple of 360 degrees, there will be equivalent. Add multiple of 360 degree or subtract multiple of 360 degree. You get the coterminal angles. Okay, angle measurement. The common units for measuring angles is the degree, little circle degree. And so we know once for rotation is 360 degree or 2 pi. Okay? Acute angle when the angle is between 0 and 90 degree. Right angle, 90 degree. Obtuse angle when your angle is between 90 and 180 degree. Or a straight angle, like a straight line. And then radian. So how do we get the radian? Radian is actually a ratio. It's the ratio between the arc length and the radius. Okay? So how to convert between degrees and radian? 180 degree is pi. Okay, so if you are given degree and you want to convert to radian, so you want to get rid of the degree. That's why you put the degree down. Then 180 degree is pi. So the degree cancel and you get 3/4 pi. Okay, and how do you convert from radian to degree? Okay, you want to get rid of the pi, right? So you put the pi downstairs, and then upstairs you get 180 degrees. So you simplify it, and you get 135 degrees. So these is some examples that convert from degree to radian and radian to degrees. Do you all remember those?
Yeah.
Yes. Okay, good. And then, okay, SOHCAHTOA. So, sine is what? Opposite over hypotenuse. Cosine?
Adjacent
over hypotenuse. Tangent?
Opposite over adjacent.
Yes. And cotangent is the reciprocal of
Sine. Oh wait, no, it's tangent.
tangent, yes. Secant is the reciprocal of cosine. And cosecant is the reciprocal of sine. So do everybody look at the sheet. Okay, the concept map of chapter 13. Do you see the hexagon here? Mm-hmm. So the way how you draw the hexagon is the natural order. You read the trig function. So sine, cosine, tangent, cotangent, secant, cosecant. And you put the 1 in the middle. Okay? And do you see there are 3 diagonals?
Yeah.
For each diagonal, the product of the 2 ends equals the middle one. So that's why here, what do you see? Sine times cosecant is 1. This diagonal?
Secant times cosine.
Yeah, this diagonal?
Tangent times cotangent.
Yes. So when you draw the picture, you can remember the diagonals what they are. And do you see the 3 upside down triangles? I call it upside down because usually when you draw triangle, you don't like this. But they're like that, upside down triangles. And we have the rule is the top 2 vertex, the sum of those 2 squares is the bottom square. So this triangle tells us that sine squared plus cosine squared is 1 square. By the way, 1 square is 1. This triangle tells us that tangent squared plus 1 is secant squared. This triangle tells us that 1 plus cotangent squared is cosecant squared. So use this hexagon to help us to memorize the trig identity. Plus, tangent is secant over sine over cosine. Okay, tangent is sine over cosine. Okay, yeah, let's continue. So, pre-now session 13.2. Okay, have a nice day.
You too. Thank you.
Thank you.